This is Dr. Pavitra AC, working as an associate professor in the Department of Computer Science and Design, ATME College of Engineering, Mysuru. Today, I'll be explaining parallel computing lab program. Now, I am going to explain fifth program, that is write an MPI program to demonstration of MPI Send and MPI Receive. First, let us see what is MPI Send and MPI Receive. MPI stands for Message Passing Interface. It is a standard which is used for parallel computing or parallel programming on distributed memory systems. Each process has its own memory space and processes communicate by sending and receiving the messages. When we say MPI Send, this information or the syntax, it is used for blocking communication function used to send data from one process to the another. When we say MPI Receive, this is used for blocking a function and it is used to receive data from another process. Now, let us see or understand the program step by step. The program says include as stdio.h and mpi.h. These two are the standard input-output functions for C language, and this program is executed in Ubuntu 11.4.0 version. Now, we are going to include the MPI header also to execute in parallel programming. So, integer main. So, here we are going to use the integers of argument C with the characters and arguments V. So, now integer of my rank and number to receive and number to send are initialized. Number to receive is initialized to 10 and number to send is initialized to 3. So, this rank is the ID. We normally say it is a rank ID. So, these two MPI number to send and receive are used as a buffer to store the received data. Now, this data has to be sent by non-root process. Okay. So, now we are going to initialize the number of elements which are actually received. So, this count says the number of elements which are actually received, and I is initialized for loop variable. Now, let us see the status of MPI status. So, this status, MPI status, it is a syntax, refers to structure to store message information. Next, let us initialize the arguments. In the arguments and argument C and argument V, so we are going to initialize this MPI execution environment and determine the rank of the calling process. So, now initially we are initializing this my rank to 0 and receive the function. So, initialize the calling determination process, MPI communication rank, which is communication world, and my rank. This is the syntax of initialization of or the determination of rank of the calling process. Next, if my rank is equal to 0, that means we are executing the code only by process with a rank 0, that is a root process. And then MPI receive. So, receive 3 integers from any source with any tag. So, we are receiving 3 integers from any source with any tag. Now, MPI receive, MPI source with any source and any tag with the communication word and status. Print the MPI source. So, we are going to use this print. Now, you are going to print print the status of the MPI source and tag that particular MPI source. If there are any error, so print the error also with the MPI error status error. So you have to accept all the messages. So the number of integers to receive is MPI int, and the data type of received element is MPI any source. And when you are going to accept the message from any process is MPI any tag. And accept messages with any tag is MPI communication vault. So now this communicator and the status are used to initialize or to know the status of the object to store the message information. Now we are going to print the above received messages. Now these messages are going to be printed with the message source, tag and error, and get the actual number of the integers received. So you are going to get the actual number of the integers received. Sorry. And then print the received data, else print the send data. MPI number to send is again 3. So all the non-root process send data to process 0 are to be printed, and number of integers to send, that is MPI int, and the data destination type, that is the process rank 0, and next MPI communication word, this is the tag which is 10, and the communication word which is the communicator, and return to 0. Now terminate the execution program and finalize it. And the output of this program will be, see, we are using here for compiling MPICC-G-O send receive.c program. Now we are going to sign the program. Now run it using MPI run with 5 commands. So we are going to see the status. The source will be 3, tag is 10, and the errors occurred are 110. So as we have given only the 3 process or the data to be received in the program, we are going to receive the data which is receiver of 0 is 73, receiver of 1 is 2, and receiver of 2 is 16. Thank you for watching the video.